Hello student, very good morning. And student, today our topic is real numbers. That is chapter number 2. And student, in this chapter, that is real number, we are going to prove that root 2 is an irrational number. Okay student, we are going to prove that root 2 is an irrational number. Student, remember these 2 points. Point number 1, we are going to suppose first root 2 is a rational number. We are going to suppose first that root 2 is a rational number, and then we will prove that what our assumption is that is wrong and root 2 is not a rational number. I will say that root 2 is an irrational number. Okay student, this is little bit difficult, but you try to understand how we are going to prove that root 2 is an irrational number. So student, we will start the solution. We are going to assume that root 2 is the rational number. The solution is, what we will write student? Solution is, let us assume that root 2 is a rational number. So right here, let us assume that root 2 is a rational number. Okay student, so this is our first step. We are going to assume that root 2 is a rational number, and we are going to finally prove that root 2 is not a rational number, it is an irrational number. So our first step is what? Let us assume that root 2 is a rational number. Student, if root 2 is a rational number, so therefore we can write root 2 in the form of P upon Q. Okay student, if any number is a rational number, so we can write that this can be written as root 2 is equal to P by Q, and we are going to suppose this. We are going to suppose, and we will write here P and Q are integers, and P and Q have no common factors. What you are going to write student? Here P and Q are integers. Here P and Q are integers, and P, Q have no common factors, and P, Q have no common factor. Okay student, so we are going to suppose that root 2 is a rational number, therefore root 2 can be written as P upon Q. We are supposing this, and here P and Q are integers, and P, Q have no common factor. For example student, if I will write 4 upon 8, this is an integer, and when I will divide student, 4 1s are 4, 4 2s are 8, so this will be 1 upon 2. So 1 and 2 is not having any common factor except 1. Okay student, so now next step is what? Next step, squaring on both sides. So we are going to square. So I will write squaring on both sides. So squaring on both sides. Squaring on both sides. So this will be root 2 square is what student? You know very well. Root 2 square, which is equal to what? P by Q the whole square, and this will be what? Square and root will cancel out, you will get 2 is equal to p square upon q square. You will get what, student? 2 is equal to p square upon q square. Now cross multiply. Therefore, p square is equal to 2 times q square. P square is equal to what, student? 2 times q square. This is what equation number 1 will give, student. This is equation number 1. Here p square is what, student? Even number. Here p square is what, student? Even number. That is what? If you take q is equal to 0, q is equal to 1, means it is multiple of 2. So we can say that here p square is even number. What will write, student? Here p square is even number. How you will say that p square is even number? Because it is multiple of 2. So when you will multiply any number by 2, you will get even number. So when p square is even number, therefore we can say that p is also even. If p square is what, student? Even number, then we can say that p is also even. Clear, student? Now further, p is also even, so we can say that 2 is the factor of p. What you will write, student? We will write 2 is the factor of p. Therefore, 2 is factor of p. Factor of p. Why, student? 2 is factor of p? Because p square is equal to 2q square. 2 is multiple of q square. So 2 is a factor of p, and already we have supposed that our assumption is what? What assumption we made? That p and q have no common factor. P and q have no common factor, but here it is very clear that 2 is factor of p. Similarly, if we will prove that q is also having factor, then we can say that our assumption is wrong. What assumption we made? We made that p and q have no common factor, and student, we are getting here common factor, and we can say that our assumption is wrong. Therefore, root 2 is an irrational number. Student, now I will suppose if 2 is a factor of p, so now let us suppose that p is even number. So I will suppose any other even number. I will suppose p is equal to 2m. So this is what? P is even number. So I am going to consider, let us consider even number is what? 2m. So I will write p is equal to 2m, and suppose m belongs to integer. M belongs to integer. Okay, student. So we are going to consider out that p is equal to 2m, and suppose m belongs to integer. Now we will put the value of p in equation 1. So put in equation 1. What is equation 1, student? P square is equal to 2q square. P square is equal to 2q square. What is p, student? P is 2m. We have supposed this. So 2m the whole square is equal to what? 2q square, and you will get 4m square. 2 square is 4, m square is m square, and this is equal to 2q square. And therefore, student, q square is equal to what, student? Just you will transfer to left hand side. So this will be what? 4m square upon 2, and you will cancel out 2 1 are 2, 2 2 are 4. Therefore, q square is equal to 2m square. Here, student, q square is equal to 2m square. It means that again here q square is what? Even. Here what, student? Here q square is what? even. Q square is even number. Okay student, q square is even number because again here q square is equal to what? It is multiple of 2. So you will multiply by 2 any number, you will get even number. For example, if 3 is what? Odd number, and when you will multiply by 2, what you will get student? 6. So 6 is a even number. Now student, here q square is what? Even number. So we can say that q is also even. What do we say student? Q is also even. Okay, and then we'll say that 2 is a factor of q. Therefore 2 is a factor of q. What do we say that student? 2 is a factor of q. Okay student, so here again 2 is a factor of q. And what is our assumption student? Our assumption is p, q have no common factor, and here we are getting 2 is a common factor of p as well as 2 is a common factor of q. So that we can say that our assumption was incorrect. So give this is the equation number 1. This is what equation number 2. Give this is what? This give 2 and this give 3. From equation 2 and 3, what we will write student? From equation 2 and 3. From equation 2 and 3, we can say that 2 is a common factor of p and q. 2 is a common factor. 2 is a common factor of p and q. 2 is a common factor of p and q. And we have already assumed that our assumption is what student? P, q have no common factor. Here we are getting common factor of p and q as a 2. Therefore we can say that what? So that our assumption, so that our assumption was incorrect. So that our assumption was incorrect, and therefore root 2 is not a rational number. Therefore we say that root 2 is not a rational number, it is an irrational number. Therefore it is an irrational number. Okay student, what will say that? It is an irrational number. So student, this is our proof. Once again I will tell you how to prove this root 2 is an irrational number. We will let us suppose that root 2 is a rational number. If root 2 is a rational number, so this can be written in the form of p upon q. Suppose here p and q are integers and p, q have no common factors. Now squaring on both sides, so you will get what? 2 is equal to p square upon q square, cross multiply. So you get p square is equal to 2q square. Here p square is even number because this is multiple of 2. So p is also even and 2 is a common factor of p. So if p is even, so we will suppose student again now if p is even, so I am consider p is equal to 2m. Suppose m belongs to integer. Now we will put in equation 1. So equation 1 is what? P square is equal to 2q square. What is p? P is 2m. So 2m the whole square is equal to 2q square. So squaring, this will be 4m square. 4m square is equal to 2q square. So q square is equal to 4m square upon 2. And then you will get what? Q square is equal to 2m square. Again here student you are getting q square is a even number and therefore q is also even. and again here 2 is a factor of q. And from equation 2 and 3 we can say that 2 is a common factor of p and q. Therefore our assumption was incorrect. Therefore root 2 is not a rational number. Root 2 is a irrational number. Okay student, so thank you for watching my videos. Have a nice day.